I would like to welcome again everyone here. Good morning from us here in Israel. We would like to thank you for being here with us. My name is Vicky and I'm Cool Automation Marketing Manager. Today with me, Roy Mukhtar, our VP Product. He was the one in charge of developing the product that we're about to discuss on the concepts. Our co-founder and VP Customer Success, Igor Midberg, is right here with us. He will be taking questions along with Philippe Agulo, who is actually our sales representative in the Asian area. And he will be the one supporting you with answering some questions as well. As you can see in our chat window, there is more information as to how to contact us in our plan for today. It's going to take us about 15 minutes to go through the concept of the webinar, the main concepts of the remote service ideas. And then we'll devote about 10 minutes to your ongoing questions. During the session, you're more than welcome to ask us questions over the chat window and also through the Q&A option right below at the bottom of your screen. When hitting the chat, you can actually see the summary of everything that I'm saying right now, including all of our contact information. And I think this would be a good idea to start. So Roy, all yours, take it away.
Thanks, Vicky. So hi everyone and welcome and thank you for joining us. We have a busy agenda today. It's based on the long and extensive research we did around remote services. And I will be happy to share with you our findings, how we see it going, and what is our offering for addressing those needs, and give you the tools for providing remote services. So let's start. In terms of the agenda, so we're going to talk about, in terms of terminology, what is remote service? What do we mean when we say remote service? Why is it remoted? Why is it important? What is the added value that it opens to companies who already have a service operations, or to companies who want to get into service operations? We'll touch a little bit about some buzzwords like predictive maintenance and big data, and see that it's much more than just a buzzword, that it is a reality and it is a helpful tools in your toolbox for providing services. And of course, we'll share with you our new remote service offering, what it has, what's the highlights of the solution, and how it can be an useful tool for you in your toolbox. So let's start. A few words about the company. The company was founded in 2007 by a team of people who have a very deep understanding of HVAC and technology, knowing the complex world of HVAC systems, where every system and every brand is actually different from one another. The company was always focused on delivering solutions to simplify external connectivity and integration with HVAC systems, to allow control, allow management, and now services. And all of this we try to do regardless of the brand that you are connected to. So trying to kind of virtualize things for you. Cool Automation is based out in Israel. We have a global sales team, and we're already successfully selling in more than 90 countries worldwide, and growing. So what is remote service? Basically, the idea is to allow doing anything that you do locally, remotely. So clearly, a lot of the things that related to HVAC still mandates going physically and being on site in order to change components and fix things. But the idea with remote service is try to reduce the time you spend on site, reduce the time of analysis done before going on site and doing the actual maintenance work. When you go on site, you have to we want to give you the tools to go there, equip as much as you can with the tools, with the information you need in order to do the work on site quickly and efficiently. That's the main idea. So we talk about something that is connected on site and actually transmits back to you, to your headquarters, over the network. So we talk about continuous and automatic monitoring. That's monitor anything you can. So it means operational status, it means service data, it means system data, anything you have in mind that can be retrieved from the HVAC system, you want to have it available remotely. Now, once you already have this data popping up to you, you would like to store it. You have to have everything stored for historic purposes. And I mean anything, even data that you think today that is not related and is not helpful, you want to store in the cloud for future purposes. So everything is up in the cloud, and then you want to have some tools that will help you remotely diagnose what's going on. So tools like graphs and some slice and dice tables, anything that will allow you control remotely without the need to send somebody to do some things for you. So tools for the technicians as if he was on site. Again, anything that can be done without physically being there. Now we mentioned having the big data stored in the cloud. So we want to leverage the fact that in the cloud we have actually infinite space to store the data. So we store all this data that we retrieve from the HVAC system, and then we let the machine do the work for us. So the machine can run automatically on the data and try to see if there are any error trends. It can run our own rules, so we can define rules that try to find anomalies in the HVAC operation and performance. All the things that the machine can do for us based on the data that we are collecting can be done, of course, remotely and pushed to us in case something goes wrong. So we have automatic alert and anomaly notification, and this is based on big data, and this can be based on the data that we actually collect. Everything that we talk about remote services, we always have to remember that we want to make sure that privacy is kept, that all the security and cyber related tools are implemented as needed. All access control is in place. So only the people who need to access systems will have this access. We don't want to allow access to people who don't have any understanding of the system. That's one thing. And another thing, for the companies that we provide service for, we have to guarantee that nobody else will have access to their system, playing with it, collecting data from it. It's very important. Privacy is one of the biggest issues when talking cloud solutions. And of course, unfortunately, we cannot talk about anything today without relating to the COVID-19. It's still around, and it's probably going to be around us for quite some time. And in terms of how it affects and how we believe it will affect remote services, we see that it's in all industries, not in the HVAC industry, customers expecting to get as much as possible remote service without people coming on site, without keeping the social distancing as much as possible. So we see customers start to demand having the option to get remote services without having technicians on site, if that is possible. So we believe that this will accelerate the pace of adoption of remote services. Customers will be willing to pay more if you offer them remote services. And that's another engine that we believe will push remote services into the HVAC world. So all in all, we're talking about, when we talk about remote service, we believe this will be the transition from a reactive or a local type of activity into a proactive and remote activity. That's a big benefit for the customer. Instead of waiting for the problem to occur, we want to analyze, to monitor, and make sure that when it occurs, we automatically and immediately act and solve the issue. So that's in general what we talk about when we talk about remote service. So let's look at the process of remote service. It starts usually with there's a customer. He has an HVAC system. Let's say it's a VRF system. Now there is an alert. One of the rooms, one of the tenants in the room complains that the AC unit is not cooling. So he's calling his facility manager, telling him that about the problem. The facility manager calls the service guy, and I'm sure you all know about this process. I just want to emphasize how the steps that it takes. He calls the service center, telling them there is a problem. They usually send him to go and check a few things, either play with the thermostat, either check that the power is on, check other stuff in the system, but they don't really have their own eyes on the system. It's somebody is doing the work for them remotely with very limited knowledge of what HVAC system is. In most cases, he doesn't find the issue, so he asks them to come over. They look for the expert that is available to go on site, and with summer in most places, most technicians are busy, so it takes time until you can visit the customer. But eventually you're sending somebody, and this somebody goes on site without knowing what is expected and what he should be prepared for. He goes on site, he looks at the system, he doesn't see anything. So he connects the service tool, but the service tool doesn't show anything, so he leaves it there for recording, and then he said he's going to come back the day after. So he's coming back the day after, look at the recordings, consult with an additional expert about what he sees in the recording, and eventually you realize that he has to go to replace some element, but unfortunately, this element is not with him in the van. So he has to go back to the office and collect that element and come another time to the customer. So we see 3 trips. Now he goes with the element, replace it, and the error is gone. So overall, when we look at this process, and of course it is an extreme process, but it's not science fiction. This is happening a lot of the times. So we see 3 trips. We see more or less 12 technician hours spending on the road, spending on site, spending on analysis. And overall for the customer, it's 4 days of downtime. So we see it's quite a heavy process in terms of solving an issue. Now let's take a look at the same error, but if we had a remote service in place. So we have the same customer with the same system, but this time he is registered with a remote service through his service contract. So we have a service contract, a yearly service contract, and since the day he has the service contract, everything is monitored, as everything is kept on the cloud, and somebody is looking on his HVAC system for him. Now, when there is an issue, immediately there is an alert sent to the service center, tells them that there is an issue with the lobby unit. Now, when they start to analyze, but in parallel, they can notify the facility manager that they know there is an issue, nothing that he has to do on his side, they're taking care of that. They bring in the expert can have remote access to the system, look at the details, look at the different parameters of the system, and try and analyze what the issue may be that caused the alert. After he did the analysis, they know what they have, they get to an understanding of what needs to be done when they go on site. So they send the proper technician with the right knowledge, with the right tools, with the potential, with the equipment that can be potentially problematic, so we can replace it. He goes on site, he look at the system, he makes sure that the analysis is indeed aligned with what he sees on site, he replaces the part, and the error is gone. Overall, we can see that the process took just 1 trip because we knew what we were going to do there. So it's 1 trip compared to 3. In terms of technician hours, much less. We 5 technician hours, 1 trip, one hour on site, overall. And for the customer, we're talking about 1 day downtime instead of 4 days. So you can see the benefits of remote service. And again, of course, it's two extremes scenarios, but the truth is somewhere in the middle. Clearly, there is a benefit of using remote service. So I would like, after we saw these two examples, I would like to show you how our solution can help you with those remote service and providing remote service. So the Cool Automation Service Provision solution is, first of all, it's a plug and play. So you have a box, you connect it to the HVAC system. And after you have done that, automatically everything populates to your cloud and to your application. Once you've done that, you have a remote monitoring diagnostic tools, and we see all the details of how everything is placed together. So I can have here issue with my Zoom. We have the analytics engine running in the background. We have alerts and audit reports, sharing capability. So if you want to share it with an expert, and eventually it's a multi-brand. So any brand, any VRF brand that you connect to it populates the same way, and I'll show you how. So the topology of how it works, we have the cloud box. This is the box that actually connects to the VRF system and provide actually remote access to the system, the outdoors, the indoors. This box populates all the data to the cloud. So there's bidirectional connection between the box and the cloud. And from the cloud, we have the application that connect to the cloud and give you all the tools for analysis, for diagnostic, for settings. Everything is done from the service provision app. So you can see it's very simple topology, very little places that you have to troubleshoot in case there is an issue. The points of connection are very clear. So let's dive a little bit into each one of the issues. So starting with plug and play. So we spoke about the topology, very simple topology. You connect to the VRF using two wires from the cloud box to the HVAC communication line, the communication line between the outdoor unit and the indoor units. Then once you have done that and connected the box to the network, and the connection to the network can be done either to the local Ethernet connection on site, and in places where either the customer have limited access to network, or sometimes the customer has a very robust network on place, but his IT guys are not allowing any external equipment to access this network. You can use a cellular router in order to connect wirelessly to the cloud. So this is also an option that you can have from us. Once done that, so the HVAC is connected, the network is connected, you press one button on the application and everything is detected automatically. So you see immediately all the units that are connected to that VRF system or systems. You can see how many outdoors, how many indoors. You see all the addresses, everything is there, and all is left for you to do is actually add some unit information that you would like to have in order to be able to better manage the systems. Information like you can name rooms, and you can add some capacity data, you can add the serial numbers, models, information that will help you troubleshoot your systems and your sites. Anything that can be retrieved from the data that is running on the communication of the VRF, we will populate automatically. We leave you just the things that are not running on that communication, and will help you troubleshooting cases in the future. So once you have done that, and that's if you come prepared and you know what you're going to, it should take a few minutes. Let's say if somebody is untrained, so we're talking about an hour or 2 hours on site, and that's it. You're ready to go. Once you are connected, you start using the application. And the first thing you see when you go to the inside application, you see the dashboard. And the dashboard, the whole idea with the dashboard is to give you a quick snapshot of what's going on all the sites that you're managing. So you start your day by looking at the dashboard. You know which are the problematic sites. It's color coded, so you immediately see if there is a red site or is a green site or whatever site you have. You know where to send your expert workforce. You know where to send your less expert teams to take care of, and you see what the errors that you have to deal with today. So if you're a service operation, I'm sure you understand what this means and the value of such a dashboard. After you've seen the dashboard and you have some alerts that you want to monitor, you can go to the system diagnostic. And here you can see a complete table of all the data points of that system. So at the top you have the outdoor units and you see all the parameters, and the parameters are the same parameters that you have in the service tool from the manufacturer, and with the same names, so the terminology is the same. You don't have to translate between one terminology to another. So if you are troubleshooting a Daikin system, so you will see the parameters for a Daikin system. If you're troubleshooting a Samsung system, then you will see the Samsung system parameters. So these parameters automatically populates with the same naming and the same conventions that you have in the manufacturer systems. So what you see here, you can see here minute by minute parameter values for each one of the units that you are managing. So you can select the parameters that are interesting for you and put them on the table. You can see the list of parameters on the left side, and you can select which units you want to look at. And you can then correlate for each one, for each minute, what were the values for each one of the parameters across your units in the system. From system diagnostics, you can go to the even deeper into the unit diagnostic. And this is going on a specific unit, either an indoor or an outdoor. And again, the parameters are changing accordingly. And in this screen, you can go into really graphic analysis of your unit. So you have all the parameters. You can see the value, the actual value of this parameter. You can go back in history and see what each parameter, what values it has in the past or in the period that you are interested in. And you can correlate that with room temperature, with set point, with the alerts. So if you had an alert, you will be able to see what were the values for the parameters that precedes that alert. And maybe it can help you understand what caused the alert. And everything we try to put in this screen, everything a technician would need in order to troubleshoot a case. So you have the graphical view, you can see the system of your view. So you have the context of the unit within a system. So you don't just troubleshoot a system, you always, a unit, you always see the context of what system it is part of. You have at the top right, you have controls. So you have, if you want to turn on the unit, change the mode or change the set points, you can do that from this screen. And you can always see the temperature on the site. One temperature is from what you read on either on the room or from the outdoor unit. And we also provide an external the temperature, the site temperature from an external source, so we can correlate that with the actual weather outside. So if there is a thermistor issue with the outdoor unit, you will be able to see that there is a gap between the outdoor temperature reading and the actual site temperature from the remote service. So we did the analysis. That's kind of a real time. But as mentioned, we try to do predictive. And how we do predictive? Predictive is by putting some rules that are built into the system. So you have the knowledge of what a VRF system is. You know what parameters, value you should expect at each operation mode. You would like to make sure that the system is running properly and it's running at the performance you expect. so you can customize your own rules to run in the backend. So let's take the example that I mentioned before. Let's make sure that we want to know that there is no, the room temperature and the set point are not, when the system is working, that should be pretty close. If we see that they don't get close within a specific time, something is wrong. So we can build a rule that monitors all the time the difference between the room temperature and the set point. And when this gap is too big and for too long, when the system is working, this may be an indication for us that something is wrong in the system. And then we have to go on site and see what's going on. So that's what we call customized rules. So you can build your own rules based on the system parameters. So you can define a rule for each one of the service tool parameter and monitor that in the backend. And if something goes beyond the limits that you expect, you will get a notification. Now, what you do with that notification is up to you. You can just get a notification and know that something is strange there. And you can decide that this notification will go automatically to somebody who will go on site immediately and check what's going on. So it's up to you what you do with the notification, but the system will trigger some kind of notification to you to follow up. So that's when you customize your own rules. Another thing is that we run some analysis tools in the backend, and the backend runs on the data that is collected, and it monitors all the time what's going on. So if you detect that there is some trending on one of the parameters and it's out of the normal, then we can alert on that as well. This what is meant when people say big data, and that's big data regardless of the HVAC system. When you collect massive amounts of data and you analyze those, you run machines to analyze this data, and eventually they can detect trends. And if a trend is picking up on one of the parameters, you can get an alert on that. All of this allows an anomaly notification management. So once you have the anomaly in place, you can manage the notification and decide who gets which notification and when. Alerts and audits. So we talked about alerts that are triggered by notification. Any alert that the system brings up, and it can be a unit alert or outdoor alert or system level alert, will be sent through notification. So you have full flexibility in customizing the notification in order to decide who gets those alerts. And the alerts gets the same manufacturer code that is sent by the manufacturer. So if you're working a Daikin or Mitsubishi, you will get the alerts codes from them, and you will be able to decide how to act on those. We'll have maintenance alerts for filters. We have anomaly alerts that I mentioned about the rules. You will get alerts in case that there is some communication issue. It can be a communication issue between our device and the cloud. So you know that at some point you're not monitoring. This may be an internet issue, it may be a device issue, but at least you know that there are issues with communication, and as long as the issue is active, you don't really have monitoring on this side. You can get an alert that you don't have communication with a specific unit. In many cases, somebody just pulls out the power from an indoor unit. This affects the whole system, but you don't know about it, and you cannot communicate with that unit. And you realize that this happened only when the system is going to an idle mode and there is problem in more than one room. So we can detect that and give you an alert on that. So all those kind of alerts are available for you, and we'll be able to decide which notification will be sent on those and to who. Audits. Audits is a way to see who was doing what on the system. Let's say your system, HVAC system, is connected on a central controller, is controlled by thermostat, and also has a BMS controlling it, and some phone application. So you want to know if somebody made a change to the unit, either change the set point, either change the mode, turn the unit on off. Any change that was made to the system, you want to know what was the source of that change. If it made on the thermostat, if it made on the control, central controller, or if it made through the application. And by having our audit screen, you are able to monitor exactly that. So you know what is the source of the issue, when it was done, and you can try and troubleshoot and understand who did what in order to understand what is going on. In many cases, somebody complains that the system is shutting off every day at 5 o'clock, and you don't know the source of that. So when you look at the audit log, you will be able to find out that there is a schedule set somewhere, and it's triggered by the BMS, or it's triggered by the application, or it's triggered locally, but you know the source of that, and it helps you analyze and understand what caused the issue, and you can solve it quickly. Sharing and exporting data. So we discussed the tools that are available for the technician, the notification that are available for you. But let's say you want to share it with external people. You have a case that you cannot analyze by yourself. You need to get an expert data. You export advice. You would like to involve the manufacturer expert. So for those cases, you are able to export all the data that is in the service app and share it with the external people. You can do it by exporting the data to a CSV file and giving them the raw data that you collected. You can give them access to the app with limited, of course, limited access. So we cannot change settings on site, but he can view on all the parameters he control. So you have full flexibility in troubleshooting the system, but you cannot make any changes to it. You can export specific alerts. You can export the audit. So you can export whatever, export and share whatever information you would like, and everything is available at the tip of your hand from the screen you are in. So it relates to the context that you are actually analyzing. And the last thing is multi-brand. So the same application, the same look and feel will be available for you regardless of the brand that you are working on. So it can be, you see here a list of connected system on this specific site. So you can see there is a Gree, a Daikin, an LG, Samsung. So the mix of all brands is available on the same application. So if you have a mix of brands manufacturer on the same site, you can look at them on the same application, have the same look and feel, same management of notifications. The only difference between each one of the brands is going to be on the parameters. And we try to make everything else look the same and feel the same. So your experts will get used to the same analysis tools, same notification tools, same process of troubleshooting cases, but the parameters will be a little bit different between if you're troubleshooting a Daikin system or an LG system or other system. We do the automatic population of the system data to fit the application. So other than parameter names, we try to do as much as possible automatically, so you shouldn't care about the brand itself. So after talking about our solution, I want to maybe take a step back and talk about what is predictive maintenance and why we believe it's not just a buzzword anymore and it's really a reality. So the numbers you see here on the circle is not our numbers. These are industry numbers. And when I say industry, it's not HVAC industry, it's global industry, it's all industries. So industrial equipment, and we can see the values of doing predictive maintenance. So when we say predictive maintenance is try to predict the next maintenance job in order to avoid the case from happening. So we see 50% reduction in system downtime eventually, because you handle the case before it becomes a major error. So by that, you reduce the system downtime. We see 10% in savings on scheduled repair costs. You have to less go on site to do the scheduled cost repairs, because you can go when you see things try to deteriorate. You can go in advance, you can reduce in going on site on your schedule routine as you were doing if you don't have predictive maintenance. We see savings on on optimization of operation. So your operation is more optimized. You use your workforce smart. You use your experts only when you need them. You don't just send the experts all the time to all the sites without knowing what's going on there. You detect the failures earlier, so it saves eventually 30% of the hardware itself, because you less need to deal with replacing parts. You replace only the parts that starts to deteriorate. You don't wait for the major case to happen. So you can see the value, you can see the numbers, clearly need to be adjusted to your service operation specifically, but these are the numbers. So predictive maintenance has value. It's not just a buzzword, and it's clear that there is value both to you as a service operation, as well as to the end customers in terms of his own operation and using the systems. I would like to show two use cases relates to remote service and how remote service was or can be a help in those cases. First case that we had with a customer using our system, in this case it's a UK-based installation, it's a high-end residential building, and it was a Mitsubishi electric system, VRF system. And the error was 5103 on the indoor unit. And in this case, this service provider was using our system, and he got a notification on this error. He got an automatic notification. The customer didn't even know there was an error. When he got that error code, he immediately know that the cause may be a problematic thermistor reading or some PCB issue. So the first thing they do, they go into the systems, try to start analyzing the cases. You can see the alerts on the screen in blue. And immediately when you put all these three thermistors, the gas pipe thermistor, the liquid pipe, and the room thermistor, you immediately see spikes on the gas pipe thermistors. When we see these spikes in the circles, it's clear that this thermistor is problematic and has to be replaced. Now, what they did, they proactively called the customer, schedule a technician to go and replace the thermistor, and once this is done, the issue is cleared. So you can see the benefits here in terms of downtime. It's minimum system downtime. The customer was not even aware that something was evolving and there is an error. He saved technician time on site. So all the analysis was done remotely in the office in front of the screen. When the technician went on site, he already got the right equipment. And at the end of the day, the customer had no hassle at all. He didn't have to go and start pulling stuff in order to check and do and make sure that all the things are in place. Everything was done remotely or by the technician, and the customer was doing what he's usually doing without dealing with the HVAC system. So this is a case when using our system. The next case I would like to show you is without having a remote service. In this case, we had an office building in Europe. It's a Samsung system, and the case was that the unit in the finance room was not cooling, and there was no error indication from the system. The ladies in the finance room complained that it's not cooling. It was a hot summer, so you can understand what it means. They called the service team for the Samsung, and they asked them to check what's going on with the other units. The other units on that system were working fine. So the only thing they had to do is to send a technician to check what's going on. So they didn't know in advance before they went on site. They came on site and they checked what's going on with the service tool, and they realized that there is a problem not just with this one unit that is not working. There is a problem with multiple other units, and they realized that the problem is with the PCB. But unfortunately, they didn't have a PCB with them in advance, so they have to schedule another visit. Overall, it's more or less like the case I presented to you on the diagram before. It took 3 days until they fixed the issue, and all those 3 days in the hot summer, the finance teams were sitting in the boiling room. If they had a remote service, they could have saved a lot of time because they could open the diagnostic tool to do exactly what the technician was doing when he came on site with the tool. They can see the graph that the expansion valve behave inconsistently, and not just on one unit, but on multiple units. And then the technician could have come with a PCB as a spare part because he could have suspect that it would be the issue. And all in all, it would have been solved in 1 day. So the benefits are clear: reduce customer discomfort time, save technician time on site, and save multiple trips to sites. So these are real cases from our experience. So to summarize the benefits of remote service. So first of all, it's a new service offering. So if you have already a service operation, or if you would like to start a service operation, you can use remote service in order to provide more in your offering. You can provide predictive maintenance. You can provide more periodic remote checkups that you have to do on site if you didn't have remote tools. You can also offer continuous monitoring, so the customer should not worry about his system. Somebody is doing that for him remotely, and for you, the machines are doing it for you and let you know when something goes wrong. So you don't have to sit in front of the system and keep on monitoring the screens. It is done automatically by the system. You have multi-brand support, so if you have a site with more than just one brand, even if you are one brand shop, in many cases you go on site and you already have the incumbent brand that you will be replacing, you will still be able to support that brand using the same tools of your own brand. And of course, faster response to cases because you get automatic alert and you know in advance before the customer calls you. So that's new offerings that you can provide as part of your service. In terms of efficiency and cost saving, so you can have analysis almost from anywhere. So your expert can sit at home, it can be at the office, it can be on the roads, but you can still have access to other sites. So that's more effective use of your expert's time. You can provide first aid guidance, so not always you have to go on site. You can look remotely what's going on and advise the facility manager or the house owner, the building owner, what to do. You of course avoid unnecessary trips, and I mentioned that it's part use of expert time. So all in all, this saves you on the costs and make you more efficient on your own operation. And of course, there is benefit to your customer, things you can sell on. Once you have these tools, you can sell them on to your customer, either as part of a service contract or as an add-on to your service contract. For them, eventually it's reduced downtime. When the system works in optimal performance, it extends the lifespan of the system. In some cases, it can get to 20-30% more in terms of equipment lifespan. They save time on the phone for remote troubleshoot. They don't have to be your eyes. You have your own eyes on the system. Energy efficiency, optimal performance means optimal energy efficiency by the system. And of course, continuous monitoring, that somebody is doing the work for them. They don't have to have somebody on site to keep on monitoring the HVAC system. As a bonus, for customers who will be using our service solution, we provide a control application. So you can offer that on to your customers. Your customers will get a control application. On their mobile, they can control their own units. Very easy to use, intuitive interface for mobile phones to control their HVAC systems from wherever they are. So how you connect to the system? So we broke it to 3 easy steps in order to start using our system. So step 1 is collect the site information. So you need to know what are the systems that are on site, what brand, what system, what models, how many units, what's the site architecture in terms of floor, where do you have network access, where you don't have a 3G connection. So all the information on site that will allow us to do the breakdown of the required equipment. Once this is collected, we do the planning, how many connectivity devices, I mean, how many cloud boxes will be needed in order to connect to the HVAC systems on site. So how will the site topology will look like? What type of subscription you will need to do in order to connect to the service application. And eventually we'll get a full cost structure of using the solution on that site. The last step is actually plug and play installation. You go on site, you connect to the HVAC system and the network. Everything is populated to the cloud automatically, and you can start using the system based on your needs. So these are very 3 easy steps to get on board with the solution. Step 3 is really quick. Step 2, we do it for you, so it's also very quick. And step 1 is for you, and you do it anyway when you start a new project or when you take a service contract. So you can see that nothing here is long and tedious process. Everything should be very quick. So we really call you to register, to schedule an online demo in order to see really a system in real time, be able to ask more questions about specific things in the application, and onboard this solution. A few words about the overall offering from Cool Automation. So we did touch the service application and all the way from the edge device connecting to the VRF through the cloud to the service provision. I mentioned we also have a control application. So customers who have service application will enjoy a mobile application for controlling their HVAC unit. So it can be on-off, set points, mode changes, as well as scheduling and some statistics of what's going on the sites. In addition, another solution that will be coming by the end of this year is our facilities management application. So when connected to the VRF system, there will be an application that will allow you to easily manage all your VRF systems and other type of HVAC system on the sites. So you will be able to manage schedules, manage users, restrict some access to some units, manage policies of who can change set points, lock thermostats, things like that. And eventually, we give you the tools to manage the energy efficiency of your HVAC systems. So everything that you will need in order to manage an HVAC deployment. So these are our cloud solutions. I mentioned the company was founded in 2007, and this is our one of the biggest market that we currently still operate on is for for integration with home automation and building management system. So our boxes, our devices connect on one end to the HVAC side, to the VRF, to split, mainly to inverter type systems, but not only. So we extend that now to other type of equipment, and that allows control through home automation. So we have drivers with the whole automation, home automation manufacturer. So when if you're an integrator of home automation or a building management system that they want to control VRF or split systems, you can do that with our devices. And I mentioned that we are expanding those devices from inverter-based to others. So we connect with other auxiliary climate systems like zone controllers, like chillers, like other sensors that may be used in those deployments in order to try and automate things more. Heating systems, radiant heating. So those kind of systems are also being added to our supported systems in order to bring everything up to the cloud or to the home automation for either control or service. So we are connecting on one end to the VRF or the HVAC side, on the other hand to our application. But since we do that and we have everything in the cloud, this also allows us integration with consumer IoT clouds. So you have Google Home, we have Alexa. So we allow, once connected through our devices, you are able to use voice commands in order to control your HVAC system using those tools from Google Home and Amazon Alexa for smart home assistants. Another option that is available to our solution is an API. So everything is done on the cloud, and we have an application that's running on that cloud, but we provide API for third parties to integrate with our solutions in order to implement their own application. So you can build your customers, or you can build your own application, your own control, your own management, even your own service. So you can pull data using API, use controls using the API. So the API is again an offering that we provide our customers, and this API is the same API that is used by our application. So nothing is hidden here. So if somebody wants to build his own customer application, this is an option. So with that, I would return it back to Vicky. So thank you for listening, and we're opening it now to questions.
Hi, glad to be back with all of you. So at this point, we would like to address some of the frequently asked questions based on our previous webinars and some of the questions that were addressed right now during the session. As I mentioned before, Igor will be the one answering and addressing them. I think that we should start with the type of HVAC systems that are compatible at this point with our solution. Igor, would you like to take this one?
Hi, everybody. So I believe that we would better go through our frequently asked questions, because what we had here were more specific ones. So
Sure.
I think they are not common.
So we usually had questions asking us about chillers and rooftops and HVAC different types, VRF system compatibility, types of brands that could work, hybrid installations. I think that would be the right direction to go now in answering the questions.
So our service app is currently working with VRF systems, brands like Daikin, Mitsubishi Electric, Hitachi, Fujitsu, Samsung, LG, recently added Toshiba, and we are expanding it to all VRF systems. Our next goal would be adding in parallel support for chilled water systems, heat pumps, and so on. It's part of our future development.
It was previously asked about for how long the data is stored.
So we are storing the data for the last 12 months, and we have an option to store it for longer period by request.
So that's good. That covers that. Is there a limit on system size?
So limitation is usually coming from the communications of different vendors. As in general, our cloud box supports up to 256 indoor units. If you have more, you just need to add another box. They're all gathered under one application eventually, so you will monitor the number of units that you have. There is no limitation on the number of units in the app. And the CloudBox can have different brands connected to it in parallel simultaneously.
We had a question on the CloudBox. Yeah, what is a CloudBox? Basically, I think maybe it would be worth our while repeating that one.
So for those who are not familiar with our CoolMasterNet, CloudBox is our hardware converter that allows using our service app. This is a box that physically converts the communication of the air conditioning system and brings the data to the cloud.
Okay. I think if you can think of any other questions, Igor, or any other content that you would like to add, that now would be the ideal time to do this. Otherwise, I think we've covered everything.
No, it seems we have covered all the questions. We are always available by emails and contact forms on the website if you have any further technical questions. And you are welcome to contact us anytime.
We would like to offer you, whoever is actually more interested in the solution itself, you can join a demonstration and set up a demonstration with our current team and have it one-on-one with specific poking us with questions on specific functionalities and challenging our ideas and maybe adding and feedbacking some of the things that we've done. Much alike the questions that we currently had, how can we measure specific parameters? So you're welcome to do so. If you actually want to join such a one-on-one session, just go to the chat box. There's a link to a form which you fill out, and that falls directly in our team's hands, and we'll be back with you to set and schedule a one-on-one demo. I think we're okay, and I think it's time for us to say goodbye. It was a great session. Thank you, Roy. Thank you, Igor. Thank you all guys for finding an hour of your busy schedule and joining us. The recording of this webinar will be sent to your email, the one that you used to register to the webinar itself. And we hope to see you soon on one-on-one demo. Thank you so much.